Hi students, in this video I want to explain the basic principle of optical fiber communication. So student, మనకు ఈ సిలబస్ వచ్చేసి మోడర్న్ ఫిజిక్స్లో ఉంది. ఆల్మోస్ట్ దిస్ టాపిక్ ఆఫ్ క్వశ్చన్ ఆస్క్డ్ ఇన్ 2013, 16, 17, 19 and 20. Nearly 6 times asked the same question. What is the question? The working principle in optical fiber communication. What is that one? Total internal reflection. But answer is a total internal reflection, but the question asking method is different. Sometimes when the light is traveling from denser medium to rarer medium, what happens? When angle of incidence is greater than critical angle, what happens? What is critical angle formula? They are asking. So to cover all these topics, now I am explaining in this video. So very important topic in modern physics, that is what? Optical fiber communication. Compulsory one question is coming from this topic. Here the basic principle of optical fiber communication is what? Total internal reflection. The main important light characteristics here we are studying, one is reflection, another is refraction. What is the two main characteristics we are discussing here? One is reflection, another is refraction. So here what is refraction means? When a light ray, see here students, I am considering this is a plane of incidence and this is normal line. What is this line? Normal line. I am writing here, this is normal, which is perpendicular to this plane of incidence, this plane. Now when a light ray is incident, when a light ray is traveling from one medium to another medium, so I am considering this is medium 1 and this is medium 2, medium 1 and medium 2. So when a light is traveling from one medium to another medium, see here, then what happens means the light ray will be refracted. The light ray will be refracted. So when a light ray is traveling from medium 1 to medium 2 or one medium to another medium, then what happens? It will be refracted. Here what is the meaning of refracted? Means the bending nature of the light. The bending nature of the light is known as refraction. So light ray will be bending. Actual direction, for example like this. So here what happens? It will be bending. So the bending nature of the light is known as refraction. When it will be existing? When light is traveling from one medium to another medium. So here this ray is known as incident ray. This ray is known as incident ray and this ray is known as refracted ray. Incident ray in medium 1, refracted ray in medium 2. And this line is known as normal line. This line is known as plane. So here the angle between incident ray and normal line, the angle between incident ray and normal line is known as angle of incidence, theta I. What is that one? Angle of incidence. Then మనం ఎలా రిప్రజెంట్ చేస్తున్నాం? theta I. Similarly the angle between refracted ray and normal line is known as refracted ray, refracted angle, refracted angle. Angle of incidence theta I, angle of refraction theta R. So student, you remember here 2 points. One is angle of incidence theta I, second is angle of refraction theta R. So when light is traveling from one medium to another medium, from one medium to another medium, the light ray will be refracted. So, here medium may be either denser medium or rarer medium. So, medium here we are discussing in two methods. One is it may be denser medium or it may be rarer medium. So, here I am explaining two cases. When light is travelling from rarer medium to denser medium, what happens? When light ray is travelling from denser medium to rarer medium, what happens? See here, I am explaining another two cases. So, first I will explain when a light is travelling from medium 1 to medium 2, the light ray will be refracted. The light ray will be refracted. Now, I am explaining here, this is plane, and here I am considering this is normal line. What is this line? This is normal line. So, here I am considering this is normal line. What is this line? Normal line. So, here medium 1, this is medium 1 and this is medium 2 or medium 1 or medium 2. Here I am considering medium 1 is rarer medium. Medium 1 is what? Rarer medium. And medium 2 is denser medium. Medium 2 is denser medium. Rarer medium and denser medium. See here students. So, here first we have a concept idea ravali. Rarer medium, denser medium. Rarer medium means it is a medium where the speed of light is more. Where the speed of light is more, that medium is known as rarer medium. Similarly, denser medium is a medium where the speed of light is less. Note down these 2 points. Rarer medium, it is the medium where the speed of light is more, and denser medium where the speed of light is less. So, here I am considering rarer medium to denser medium light is travelling. So, when a light is travelling from rarer medium to denser medium, the refracted ray moves towards the normal line. The refracted ray moves towards the normal line. This is normal line, and this is incident ray. I am writing IR, incident ray. This is refracted ray. So, when a light ray is travelling from rarer medium to denser medium, then what happens? The refracted ray moves towards the normal line. Remember students, very, very important point. Similarly, I am considering when light is travelling from denser medium to rarer medium. So, here I am explaining, this is plane, and here I am considering this is normal line. Now, here I am considering this is medium 1 here, this is medium 2 here. Medium 1, medium 2. Medium 1 I am considering here denser medium. What is the medium 1 here? It is denser medium, and medium 2 is rarer medium. Medium 2 is rarer medium, denser medium and rarer medium. Just now I explained denser medium means what? It is the medium where the speed of light is less. Rarer medium, it is the medium where the speed of light is more. And here I explain, when a light ray is travelling from rarer medium to denser medium, the refracted ray moves towards the normal line. Now I am explaining when a light ray is travelling from denser medium to rarer medium. This is denser medium, incident ray. When light ray is travelling from denser medium to rarer medium, then see here, after refraction, the refracted ray moves away from the normal line. So, this is what? Refracted ray. Students, very important point. So many bits are asking here. When a light is traveling from rarer medium to denser medium, the refracted ray moves towards the normal line, and when light ray is traveling from denser medium to rarer medium, then the refracted ray moves away from the normal line. So here when it moves towards the normal line, angle of refraction will be less, and here when it moves away from the normal line, then angle of refraction is more. So here theta I greater than theta r, here theta r greater than theta I. What is theta I? Angle of incidence, and theta r is angle of refraction. See here students. So just now explain, when light is traveling from denser medium to rarer medium, what happens? The refracted ray moves away from the normal line. See here, this is plane of incidence, plane. Now I am considering this is normal line. Students, now I am explaining total internal reflection concept. See here. So this is what? Normal line which is perpendicular to plane. Normal line. Now I am considering this is medium 1 and this is medium 2. Medium 1, medium 2. Here very important, the first bit assumption considering here, consider medium 1 is denser medium. Medium 1 is denser medium, and medium 2 is rarer medium. What is medium 1? Denser, medium 2 is rarer medium. They will ask question, to obtain total internal reflection, medium 1 must be denser medium, medium 2 must be rarer medium, or they will ask question, to obtain total internal reflection, the light ray must propagate, the light ray travel from dash medium to dash medium. So answer, first dash is denser medium, the second dash is rarer medium. So very important, here medium 1 must be denser medium, medium 2 must be rarer medium. So now one light ray I am considering one light ray. This is a light ray is traveling from denser medium to rarer medium. So when a light ray is traveling from denser medium to rarer medium, just now explain, the refracted ray moves away from the normal line. Away from the normal line. Now I am increasing this angle of incidence. I am increasing the angle of incidence. I am considering one more light ray. I am increasing here the angle of incidence. See here, this is the first angle, I1 I am assuming, this is I2 I am assuming, where I2 is greater than I1. Then after refraction, the refracted ray moves further away. See here, this is angle of refraction R1, this is angle of refraction R2 with respect to second ray. First ray, second ray. So student, you understand this concept. When light is propagating, when light is traveling from denser medium to rarer medium, after refraction, the refracted ray moves away from the normal line. Like that I am increasing angle of incidence, here angle of refraction also increases. Now at particular angle of incidence, the refracted ray travels along an interface, along plane of interface. See here, at particular incident ray, at particular incident angle, the refracted ray travels along this interface, along plane of incidence. So when refracted ray travels along this plane, then what is the angle of refraction here? Angle of refraction is 90 degrees. What is angle of refraction here? 90 degrees. Student, very, very important point. So, at which angle of incidence, the refracted ray travels along the plane of incidence, or at which angle of incidence the angle of refraction becomes 90 degrees, that angle of incidence is known as critical angle. What is the angle of incidence name? The angle of incidence name is critical angle. So, very, very important point. What is critical angle? It is an angle of incidence. It is an angle of incidence at which the refracted ray travels along plane of incidence. So, here the condition is, critical angle condition is, when theta r is 90 degrees, condition when theta I equal to theta c. When theta I equal to theta c, then theta r equal to 90 degrees, then the angle of incidence is known as critical angle. Here, according to Snell's law, what is Snell's law? N1 into sin theta 1, N1 into sin theta 1 is equals to N2 into sin theta 2, N2 into sin theta 2, N1, N2. Students, now here I am writing what is N1, that is refractive index of medium 1, and what is N2? Refractive index of medium 2. N1 refractive index of medium 1, N2 refractive index of medium 2. Alage theta 1 is angle in medium 1. So, in medium 1 which angle we are considering? Angle of incidence, and theta 2 angle in medium 2, that is angle of refraction. So, I am writing here N1 into sin theta I is equals to N2 into sin theta r, because in medium 1 we are considering angle of incidence, in medium 2 we are considering angle of refraction. Now, apply this condition. Angle of incidence is known as critical angle when angle of refraction is 90 degrees. So, I am writing N1 into sin theta c is equals to N2, because sin 90 is 1. Then sin theta c is equals to N2 by N1. Sin theta c equal to what? N2 by N1. Then critical angle theta c equals to sin inverse of N2 by N1. Students, very, very, very important formula. Critical angle formula is what? Theta c equal to sin inverse of N2 by N1. So, here we consider light rays travelling from denser medium to rarer medium. When light rays travelling from denser medium to rarer medium, what happens? The refracted ray moves away from the normal line. At a particular angle of incidence, what happens? The refracted ray travels along the plane of incidence. That angle of incidence is known as critical angle. Now, again I am considering one more incident ray such that the angle of incidence, that particular ray is greater than critical angle, So, here I am considering one more incident ray. This is one more incident ray, fourth. And what is the condition here? This fourth incident ray condition, theta I, angle of incidence, is greater than critical angle. So, when angle of incidence is greater than critical angle, then the refracted ray will be totally reflected in same medium. The refracted ray will be totally reflected in the same medium. So, this phenomena is known as total internal reflection. Total internal reflection. So, in 2013, 2016, 17, 19 and 20, 6 times they asked question, same question. What is the working principle in optical fiber, or what are the conditions to obtain total internal reflection? All these questions are related to total internal reflection. So, here again I am asking, what is a total internal reflection? Means it is an angle of incidence at which the refracted ray will be reflected in same medium. The refracted ray will be reflected in same medium. That is known as total internal reflection. So, in optical fiber we are considering two materials, one is core material and another is cladding material. Core material, here you assume this is medium 1, cladding material is medium 2, remember, and core refractive index is N1, cladding refractive index is N2. So, same operation of optical fiber explained, or working of optical fiber explained by using total internal reflection. So, in our ESET exam they are asking question, the first question is what? The working principle in optical fiber is total internal reflection. So, what are the conditions to obtain total internal reflection? Means there are 3 conditions. The first condition I am writing here, the light ray must travel from denser medium to rarer medium. The light ray travel from denser medium to rarer medium. This is the first condition. Denser medium to rarer medium. So, what is the meaning of denser medium? Here denser medium is a medium where the speed of light is less, and rarer medium, it is the medium where the speed of light is more. This is the first condition. The light ray must travel from denser medium to rarer medium. And the second condition, refractive index of medium 1, that is N1. Refractive index of medium 1 must be greater than refractive index of medium 2. N1 must be greater than N2. So, what is N1 here? Refractive index of medium 1, and N2 is refractive index of medium 2. And the third condition is angle of incidence theta I. Angle of incidence theta I must be greater than critical angle. Angle of incidence theta I must be greater than critical angle. So, when these 3 conditions satisfy, then total internal reflection phenomena will be existing. So, what is a total internal reflection? It is an angle of incidence at which the refracted ray will be totally reflected in the same medium. Total internal reflection. For that purpose, what are the 3 conditions? The light ray must travel from denser medium to rarer medium, and refractive index of medium 1 must be greater than refractive index of medium 2, and third condition is angle of incidence must be greater than critical angle. So, critical angle means what? It is an angle of incidence at which the refracted ray travels along the plane of incidence. So, what is critical angle definition here? Theta c equals to sin inverse of n2 by n1. So, number of bits are in our Saimedha.in app practice sets. So, students, read the questions carefully and solve all optical fiber communication bits.